Let's start the session. So, I hope I'm audible. Can any one of you confirm just quickly?
Yes,
Yes,
sir.
I can't hear you guys.
Yes, sir, you're
Yeah,
audible.
fine. Thanks. So, yeah, the first question is from instrumentation. Although it is sessions of electrical, but the subjects are common. So, I'm taking this control system question from GATE 2020 instrumentation, technical question 6. Phase lead networks has a transfer function of g of s 1 plus 0.2s upon 1 plus 0.05s. The angular frequency at which the maximum phase shift for the network occurs is which are the options that satisfy. So let us see how will we solve this question. So this transfer function is given. The no, ignore this. Yeah. So g of s is equal to 1 plus 0.2s upon 1 plus 0.05s, where if we substitute s is equal to j omega, we get it as 1 plus 0.2 omega in complex terms and 1 plus 0 j 0.05 omega. Now when we have to find the angle of this j omega term, what we do is we take the complex angle, and that is tan inverse 0.2 omega for the numerator and minus of tan inverse 0.05 omega for the denominator. Now by applying trigonometric formula, tan inverse of 0.15 omega upon 1 plus 0.01 omega square is the equivalent combination of these angles. Uh, Now the differentiation expression to find the maximum uh, phase angle delivered by this maximum phase shift by this network, we need to find the omega at which this maximum phase shift will occur. So this angle represents the phase shift, and when we differentiate this angle expression, angle of g of j omega with respect to omega, this expression tan inverse of this, we get this long expression uh, where it is the differentiation of tan inverse x is 1 upon 1 plus x square. Uh, Furthermore, by expanding the inner terms, we get this. So this expression is of the interest when we solve this, which comes from that angle expression here, and d of angle of g of j omega with respect to d omega is amounted to 0. By solving this, we get omega square is equal to 100, and omega comes out to be 10 radians per second. So the answer to this question is 10 radians per second. Okay. So any doubts in this question?
No, sir.
Okay. Mm, Let us take a easy question. Uh, so GATE 2020, again control systems, instrumentations, technical question 5. A differentiator as a transfer function holds what a phase increases linearly with frequency, magnitude remains constant, magnitude increases linearly with frequency, or magnitude decreases linearly with frequency. So it's a fairly simple question. You can just analyze this question from a Bode plot. So let us take a basic differentiation expression. Voltage across inductor is L di by dt. Let us take the Laplace operation on both the sides. VL of s is equal to S Li of s. This is the differentiation operation where s term is introduced. Now when we try to plot the Bode plot of only this s, we know that uh, it increases with a 20 dB per decade. Okay, and the angle contributed is 90 degree. Okay, when it is in the numerator, and the if it is opposite, like if it was 1 upon cs in the impedance, so 1 upon s would have contributed minus 90 degree, and it would have been decreasing by 20 minus 20 dB per decade slope. So as you know, in control system, if 1 by s is one pole at origin, so it decreases by minus 20 dB per decade. Here it is in the numerator in the form of a 0. That's why it will go in 20 dB per decade with a phase angle 90. This basically comes from the previous question which we saw, where we put s is equal to j omega, where the j omega is representing that 90-degree phase angle, where real term is 0, and with frequency, basically this is the frequency axis. So as omega increases, the magnitude also increases linearly and phase remains constant. So magnitude increases linearly with frequency. C option matches. Phase remains constant. So I think C option is the correct option. So any doubts in this?
No, sir.
Okay. Okay. Mm, yeah. Again, this is a pretty much standard question in digital electronics. So from again GATE 2020, instrumentation, common to both electrical and instrumentation, this concept. So technical question 8. So given a function of a b c d, it is a summation of min terms. So 0 1 2 6 8 9 10 11 and don't cares 3 7 14 15 is a boolean function, where m represents min terms and d represents don't care. The minimal sum of products expression for f is. So what will be the logic that will follow this pattern for this function of ABCD? So let us plot the K-map for the following expression. So, uh, so ABCD is given here 0 0 0 1 1 1 1 0. If someone doesn't know what are K-maps, it's basically a representation of a truth table in a unique way, such that you can find the function that is to be realized. So it's just a rearranged form of a truth table, where the 0 0 0 1 1 1 and 1 0, you will see that only one bit is changed at a time. 0 0, then 0 1, the second bit is changed. From 0 1 to 1 1, one bit is changed, that is the first. From 0 1 to 1 1, first bit is changed, this is 1, that first bit. From 1 1 to 1 0, only the second bit is changed. So nowhere from left to right or top to bottom in the left side, uh, any two digits are changed simultaneously. Only one digit is changed. And these two combinations 0 0 0 0. So ABCD 0 0 corresponds to 0, where it is min term is given as 1. Then 0 0 0 1 is 1 in binary. 0 0 1 1 is 3 in binary, which is given as don't care. 0 0 1 0 is 2. So 0 1 2 3. So like that in binary, and so till 15, 0 to 15 we have to construct. So let us first see the first condition. So when we put m equal to 0, here we'll put it as 1, then again 1 1 here, then 2 is here, then directly 6 is here, 1 0 0 0, that is, sorry, that is 8, 6 is here, 0 1 1 0 here, and then 8 9 10 11. Basically this bottom row is the 8 9 10 11. So this is 8 9 10 11, like this, and these are the don't cares, which doesn't matter, can be high or it can be low. According to our convenience, we can assign them whatever we want. So this x are the don't care conditions. So let us see which is the group we can form to solve this question. What is the expression? So we can only form groups in the multiples of 2's or singular, like 1 2 4 8, like that. So here we can form a group of 8 ones. Here if we take this x as 1, so from bottom if we wrap around like this, so we get a two blue boxes. If we combine, we get 8 ones simultaneously, and they follow the logic 1 when b is 0, and they don't depend on a, whether a is 0 or 1, they will be 1. So when b is 0, they are 1, and they don't depend on c and d either. Whatever is cd, they don't care. Basically they are 1 irrespective of c and d. Only when b is 0, they are 1. So they will follow the logic b bar. Okay. Now the next group that is remaining is this. To account for this central group, we couldn't have taken this group in this because it is in the form 1, 2, 4, 8. So now we'll take the group of these 8 ones. So if we look at this, A and B are changing. These are 1 irrespective of them. So A and B won't come in this. And this also, in this row also, C is 1 and D is changing from 1 to 0. So it doesn't also depend on D. But when C is 1, they are 1. So when the output when the input C is 1, this are 1. So other term is C. So the first was B bar. When B was 0, output was 1. So therefore B bar to convert 0 to 1 logic. And the next was C. So when we put summation of the min terms, sum of products, it is B bar plus C to account for this blue group and the red group. So answer is B, option B. F is equal to B bar plus C. Any doubts in this question?
No, sir, clear.
Okay. I hope other two guys uh, also don't have any doubts. Can wait. I have completed the 3 questions that were intended for today. So I'll wait for 1 minute. Okay, fine. So if you guys have no doubt, you guys can leave. I can wait for 30-40 seconds more.
Thank you, sir.
Yeah, thanks.
Sorry, is there any questions based on the QM map?
Which? Sorry.
QM map, sir.
No. Today I don't have. But let's see. I have been assigned networks and controls, and somewhere I get these questions also for digital from the topics that are given on the GATE portal. So
Okay.
maybe from one of few of my colleagues I can tell them to take in the coming week.
Yes, sir. Okay.
You can check the sessions from ECE also, not just from electrical. There, if you can find those topics.
Okay.
Yeah. Fine. Thank you. Thanks a lot.